This week we're going to be talking about disaster recovery. And one of the key things to remember when you go about implementing it or designing a disaster recovery strategy is that it's almost always more complex than you think. And I say that because I've actually had to do this myself several times, work through the process. It's usually a long and drawn out process, particularly for complicated and complex systems. And the overarching theme when coming up with a disaster recovery plan, when coming up with a disaster recovery strategy, is trade-offs. When I'm talking about trade-offs here, what I mean is there's generally a cost associated with downtime or some sort of other service disruption or degradation that's caused by a disaster or an event. And then there's the related cost of avoiding that particular scenario or that particular degradation of service. The two are generally related. How much you're willing to tolerate of one will dictate how much you have to spend for the other. And you'll see a lot of figures thrown around when talking about uptime, when talking about availability. You'll hear 5 nines, you'll hear 6 nines, you'll hear 3 nines, 4 nines, 2 nines, all that sort of stuff. What a lot of people don't realize is that there's some very simple math that you can do to actually map those figures to actual time. And we'll go into that just briefly. I'll give a few examples. But the key part then is that the trade-offs, and the reason why this is key is because the cost of guaranteeing a level of uptime or guaranteeing zero downtime, if you like, if that's your ideal, no downtime, 100% availability, goes something like this. You'll notice that, although drawn somewhat poorly here by me by hand, this closely resembles a sort of asymptotic curve for mathematics, so that as you approach zero downtime, the cost is skyrocketing. So generally people are going to want to find the sweet spot here. In other words, how much downtime are you willing to tolerate, because that costs you X amount, versus how much you're willing to spend to offset the chance of that happening. So it's a pretty simple calculation, but actually figuring out where on this curve you should be requires certain things. For one, you need to know exactly how much a second of downtime actually costs you. What is that cost? Now, some companies, let's say for example a company that's purely based on advertising, they're going to have a direct relationship in terms of downtime related to how much they're making serving ads. So if they can't serve ads, they know that they currently make, averaged out over a day, $1 million a second. Okay, so for every second of downtime, it's going to cost you $1 million. You know, however, that to reduce the downtime all the way down to zero is going to cost, let's say this limit here is something like $100 million. That seems very expensive, and $100 million, that's at 99.9999% availability, so very low. To give you an idea of exactly how low 99.9999% is, 30 seconds of damage over a year would give you approximately this type of availability. And with that in mind, you know that, or you've estimated that, to guarantee that there's only 30 seconds of downtime for your website, for your ad serving platform, whatever you're actually looking to guarantee is working, 30 seconds will cost you $30 million. So there's obviously a disparity here. You know it's going to cost you $100 million to only have 30 seconds of downtime, but you only lose $30 million for 30 seconds of downtime. So there's a $70 million gap there. So this is the kind of the trade-off between the ideal and reality. So you're going to look at this and say, well, there's no point in spending $100 million on this. We'd rather take the $30 million hit, unless there's some sort of ancillary effect here. In other words, if having 30 seconds of downtime can severely damage your brand, your company image, then there might be a multiplying effect or an additive effect onto this $30 million in revenue that you're losing. So that's a call you're going to have to make when you're deciding exactly what downtime costs to you. But if we just do it as a straight revenue projection, $30 million for 30 seconds. So you've decided that that's a little bit too much. That's a little bit too much of a gap. You'd like to have great availability and great uptime, but there's no point in spending $70 million where you don't have to. So what do? You decrease your requirement. You say, well, 30 seconds, be 4 nines, depending on where you start counting, 4 nines or 6 nines here. This seems a little excessive. What about if we go down to 99.9998%? Now that doesn't seem like much of a decrease here, but you basically have doubled. You've gone from 30 seconds to 60 seconds. 60 seconds will give you this. Now, I'm using just 4 decimal places of precision here, but this is actually how this works out. And by accepting 60 seconds of downtime, you know that that's going to cost you $60 million. Right? But this is going to be significantly further down here on the curve. This could be here, and this is, say, $50 million. what it's going to cost you to guarantee that there's only going to be a minute of downtime every year. So $50 million spent ensures that you can lose a maximum of $60 million for the year. And now you're starting to get into sort of the sweet spot where the two are starting to be associated quite quickly, and there's going to be some fudge factors here and everything else. This wouldn't necessarily be a bad thing to be aiming for. So you go to your ops team and you tell them, okay, our tolerated downtime for this product is 60 seconds over the entire year. That's what you can have in terms of your downtime. And that's when the conversation will really start. The conversation will focus around what is down. How do you define down? Is it when the entire website is non-responsive? What if there was a lesser version of the website that you could run that still served ads and got you most of your revenue, but didn't get you the full amount, and allowed a longer period of downtime there, let the ops team do their work, or lets them flip over into a sort of a maintenance-only mode, do the work they need to do to get everything back up and running? Then it's not quite as simple an equation. You can't just do straight, 60 seconds downtime costs me this. Maybe when you go into that maintenance mode, you only make half the revenue. So instead of it costing you $1 million a second, it's $500,000 a second, etc., etc. So these conversations tend to spiral. This is why disaster recovery is almost always more complex than you think.